Hey everybody, thanks again for those of you joining us here live on Twitch today. We are coming in here live from the AWS Loft in San Francisco, where we're spending the whole day here today talking about serverless technology. Now, all this week here at the Loft, we've been covering a recap of new launches and kind of a catch-up on things since AWS reInvent, our yearly user conference, which just happened at the end of 2018, end of November, first week of December. Here all day today, we've been talking about serverless. And so we're now at the final stretch here, the fifth of 5 talks. And so if you're just joining us, thank you for joining us here. I've got a bunch of great, awesome crowd here at the AWS Loft. Thank you for all of you who've come here in person and stuck around for this or just joined us. So far today, we've covered a wide range of topics inside of the serverless platform here at AWS. We started talking about Lambda in serverless applications. Talked a little bit about our tooling, so AWS SAM CLI. Talked about Lambda layers and the Lambda runtime, 2 new core awesome capabilities inside of AWS Lambda. We just spoke about Amazon API Gateway and the capabilities and the power of building APIs with it. We're going to finish up here with another really incredibly important part of the serverless platform, or portfolio, I should say, here at AWS, which is AWS Step Functions. And so, again, for those of you just joining, my name is Chris Munns. I'm a principal developer advocate for serverless at AWS. Been here for a little over 6.5 years across a number of different roles, but representing the serverless space for the last 2 years. I'm based in New York City, and I actually come from a startup background, having worked in ops or DevOps or SRE, whatever you might want to call it today, for a number of startups back there. So, all day today here, we've been talking about the concept of the topic of serverless. This is a really hot topic in the industry. If you got to catch any part of AWS reInvent, either in person or via the live streams we had for that, serverless was a hot topic that we talked about. There was a lot of energy and buzz around. We had a number of really exciting announcements that came out in the period around there. And so today we've been recapping some of those and then kind of bringing everyone up to speed with where we are with some of these various products. Now, today we're going to talk about step functions, which is a really incredible, powerful tool and a really important part of building a serverless application. So let's talk a little bit about what a modern application could look like with Lambda. We've talked and seen some really brief examples here today. But you can imagine a world where you had a lot of different Lambda functions talking to all sorts of different parts of your infrastructure. You could be talking to queues or databases or HTTP endpoints or API endpoints. They could be talking to each other. There could be all sorts of things that you might need to do to build the complicated capabilities and needs that you have for your product. And if we think about each of these motions, each of these connections, each of these things that we're talking about, there's probably lots of things that we might want to do with those. And there's lots of ways that we want them to interface with each other and the downstream services that they're talking to. And so what we hear customers ask is they say things like, I want to sequence Lambda functions. So Lambda function A happens, and then Lambda function B. Parallelization. I want these 4 things to happen, and at the end, reduce back the result and do something. Being able to basically have a decision tree. So based on the results of A, I want it either to do C or D, but not have to do both of them. And then there's things like failure handling, retries, and all the kind of complicated logic that goes into it. Now, these are things that people have wanted to build into applications for long before Lambda existed, for example. But in Lambda, you have some nuanced aspects about it that make some of these things more complicated. Lambda functions today have a default time limit of 15 minutes. So that means that the maximum duration of what you want to do in that function and what you want to talk to is limited by that 15-minute amount. There's also aspects, someone had a great question earlier, around limits for storage size inside of Lambda. So Lambda functions give you 512 megabytes of temp storage. And if you needed to process a 1 gigabyte file, you couldn't do that in Lambda easily today. And so if we think about some of the ways that we might want to try to accomplish this list of things here with Lambda, there's a couple ways we could do it. But we'll talk about more of a specific use case here, again, in this serverless context. So let's say that I want to book a vacation. In this case, I want to go to the Grand Canyon. But not only do I want to book a vacation in the Grand Canyon, so not just a flight and a hotel, I'm also going to reserve a car. And now, if I can't reserve the car that I want, then you know what? I don't want to go, and I'm going to cancel my trip. So I've got this logic that I need to accomplish. I need to book a hotel. I need to book a flight. I need to book a car. If any of those don't work, I'm going to need to roll back this process that I want to go through. Now, there is the option of having one giant Lambda function that has sub-functions inside of it. And you see kind of that diagram here. And again, we have the issue of coordination, of handling failures, of handling retries, of that maximum timeout. And so that makes this kind of less than ideal. We could do function chaining. And this is where you can definitely run into danger of having function A call B, call C, call D, and so on and so forth. But again, if somewhere towards the bottom of this diagram we have a failure, how far back do we have to coordinate that failure back up to the upstream? Now, the way that our application architects have handled this for a long time now is maybe they'll use something like a database to manage state. You might also do something like try to use queues or message buses to pass messages between systems and essentially pass an ever-growing amount of state that you track across all of that. And so a lot of these things are complicated, sophisticated in of themselves, and not necessarily ideal. And so that led us to building AWS step functions. And apologies here, the word AWS step functions seems to be blending in a little bit on the slide. And so what we see here is an example of a workflow diagram, which is actually taken from the step functions console. And so step functions initially launched with the ability for you to coordinate Lambda functions. As we'll talk about here in a moment, you can actually now coordinate way more than just Lambda functions. But it's meant to handle all of this complexity that we just talked about. So with step functions, the idea here is you could really easily, quickly go and fire up this workflow orchestration, be able to do coordination between services without having to write a lot of code. And then ideally here, one of the key aspects about this as well is it manages the state for you really, really well. So it's highly available, it's durable, it scales. And you don't have to think about the orchestration software as something that you need to maintain. Now, I had mentioned that this first launched for supporting Lambda as an action. But one of the things that we just launched a couple weeks ago at AWS re:Invent 2018 is we effectively call richer workflows. But what it allows you to do is integrate with a lot of other services at AWS. So this is things like Amazon SNS or SQS, where you can put messages into a topic or a queue. Amazon SageMaker and Glue, which are, well, Amazon SageMaker is part of our machine learning space. You can kick off SageMaker jobs. You can also kick off AWS Glue, which is an ETL service, or AWS Batch, which is a batch service. And then lastly, you can also now cause container-based workloads to start up. So for the places where the limitations of Lambda don't work well with what you need to do, you can actually now coordinate that into something like Fargate or ECS. And so really what it does is it makes step functions just that much more applicable to what you're trying to do, and it can allow you to have some really interesting orchestration workflows for your code. So again, when we talk about it being able to allow you to quickly build out and iterate what you want to do, we actually have a visual editor for step functions here. I'm going to show you that here in a little bit. And so we can map out basically the various aspects of what we have. And so the diagram that we see here has a couple of different capabilities in it. The first thing that we see, these green boxes here, you see a task. So each green box represents a task. And a task could be, again, a Lambda function or potentially an integration with any of these services that I mentioned before. When you look down at the green box, the second one down from the top, which says image type check, out of that can come what's called a choice. So the two kind of arrows that come off of that represent a decision tree where it's actually step functions handling that. So the image type check returns a result, and then step functions decides which path we go down after that. We could store image metadata, or we could have a failure action that we potentially handle some way. If you go below the store image metadata box, and you go down to where there's kind of a dotted outline around the rest of the workflow here, you see a parallel task. So this is going to kick off two things in parallel. And then after both of them are done, from the recognition task, you will have the add recognized tags. And then after that, this workflow ends. And so again, we've seen kind of a couple different things here: task, choice, fail, and parallel. These are all capabilities of step functions. And now you can do this in the UI, or you can also define this in a JSON DSL that we have. Apologies here, some of the fonts aren't showing up exactly the way that I had hoped, but there is inside of this resource here, an Amazon ARN that is passed in. So the JSON itself is also pretty straightforward and pretty powerful. And then we can see these executions happen, and we can do this from the console, from the CLI, or from an API. Typically, you're probably going to integrate this in some form or fashion with a monitoring or metrics tool. And again, it's coordinating all these various things. So when it executes a Lambda function, Lambda still does all the logging and stuff that it needs to do. And so all of those things just work the way that they would normally. So we can do things like run steps in a sequence, right? So we see here the 3 steps that I mentioned for my workflow. For booking my travel, I'm going to book a flight, and then book a hotel, and then book a car. But what I really want to do is be able to handle any sort of failure situation. So if I go to book my flight, and that works, great, then go book a hotel. If my hotel fails, then I'm going to go down and cancel my flight. However, if I can book my hotel, then I'll book a car. But if that fails, then I'm going to cancel my hotel and then cancel my flight. And so you can see here basically the logic that I can put in place to unwind failures that might happen or to successfully go through the flow that I have in order. And so each of the dotted boxes here could represent, again, something like a Lambda function or a Fargate task or ECS task. And then all of the arrows represent basically decisions that are being made by the step function service. So let's say, though, that one of those steps failed for some reason. So maybe a Lambda function times out, or it receives an error from another service. So one of the things that step functions can do for me is it can actually handle that failure in a retry. Maybe you talk to an API that's a little flaky, or that maybe has scale issues, whatever it might be that could happen. And so with this here, we can handle all aspects about the retry, things like max attempts to retry, if there's a back-off rate, interval that we want to do that retry in. And so again, we can take this code that we might have potentially put in our actual application code and tell step functions to handle it on our behalf. We can also do things like catch exceptions. So going back to that decision tree that we had back there before, we can actually output from our Lambda functions custom error codes or custom error messages, and then basically react based on that. So we can get really fine-grained about what it is that our service tells us what went wrong and how it should potentially handle that thing. So key things about step functions that it helps you with is automatically scaling, not losing state. So again, if you were doing this all from a Lambda function by itself and it handled coordination and it died, there goes your state. Helps again with errors and timeouts. Pretty easy and auditable. And the auditable aspect is a really key thing that we'll talk about here in a moment. Now, in terms of all the different things that you can do, we've seen the ability to do tasks and choices and parallelization. There are a couple other types of states that it supports. So it supports a wait state. So imagine that you need to kick off some sort of action, and that's going to take time. You can basically have the equivalent of a sleep, if you will. There's failure states, and then succeeded in pass states. And so really just a couple of basic types, but all of the ways that you could put them together is where the combination of interesting things can happen. So you mentioned before that this is expanded beyond just for Lambda. You can now interface with all these different services. And so as part of this, you can imagine all sorts of different ways that you can build really complicated workflows that kick off things and do stuff. You could have, given things like the wait state, you could put messages into a queue. Something else takes that stuff out of the queue and acts on it. You can have a wait state that defines waiting for a certain period of time and then attempts to query a database or look for something to happen there. We also support the ability for you to do what's called a long pull. So this allows you to run any code that you want on, say, EC2 or in a container or even in your own data center, pulling a step function, looking for work to take on. And so you can do work with step functions out of band from just the services that are directly integrated into it. So I haven't today in the slides that we've had talked a lot about any customer use cases. But just to give more examples towards what's possible here, I'm going to come through a couple. And so these are all public case studies that we have from customers that are using step functions. And again, I want to walk through what's capable with them. So there's a company called foodpanda, and what foodpanda does is it enables you to be able to, as a restaurant, use foodpanda to help with delivery. So instead of having to have your own delivery team, you could use foodpanda to help coordinate that. And so, oh, excuse me, that was an out-of-place slide. And so inside of foodpanda, they use step functions. And so they have a really basic flow here for part of their workflow. And basically what they want to do is they want to identify a driver that's available to bring food to you. And so what they do is they have a task which pulls in all of the available vehicles. They then run what they call their assignment algorithm. So where does it make sense to grab a vehicle from in relation to the restaurant and to the orderer? They can then dispatch that vehicle, inform the customer, or if they can't dispatch the vehicle, they will say that the vehicle cannot be contacted and potentially have an error. And so again, each of these bits of work is a separate service, is a separate Lambda function, what have you. And then they also have a failure state for no vehicles found, which is if they are unable to load any available vehicles. Now this is just a snippet of a larger workflow that they have, but again, something that you can kind of relate to here. There's another one that we have here. So Thomson Reuters, which provides all sorts of different services in the media, entertainment, financial sector space. They have something where they get 350 news clips per day, and they need to transcode them into 14 different formats in as near real time as possible. And so they were able to use step functions to greatly speed up this process. But let's go ahead here and look at part of their workflow. And so what they actually do is they take video snippets, and then they have functions that do introspection on them and gather metadata about them, look at how long they are, split them down into smaller segments, and then basically transcode those individual segments and merge them back together. And so because they're using step functions, they can break up all those pieces of work. Each of those pieces of work could be running at different levels of parallelization in terms of there will be multiple of these executions happening at any point in time. And then again, this has brought down the time that it's taken them to get these out from 20 minutes to 2 minutes. And in a world where you're trying to get news out quickly, this can be really valuable. There's a company called Outsystems, which offers up IT automation and management services. And they do something where they help people with doing things like database backups and resizing and other capabilities around data management. And so I included this example just strictly due to this diagram. This is a really, really, really long step functions workflow definition. I couldn't even make it large enough to read the whole thing here. And what we see is something like 60 or 70 different tasks and actions. And it may be a little hard to tell the faintness of the lines here on the slide, but all of the various failure states that they handle for and how they do this. And so this has been able to help them reduce costs, speed up the way to resolve this. And again, they're not writing the code that handles all of this in their Lambda functions. Another example here with Coca-Cola, where they had to update those little barcodes that you have on the food and the nutrition facts based on changes to FDA regulations. They were able to do this. It used to take 36 hours. Now it takes 10 seconds. That's a pretty drastic change. And so they use a number of different AWS services. They use step functions. They use SNS. They use Lambda, Aurora, API Gateway, all that stuff. But in that case, this is what their workflow looks like. And it's a workflow that has a couple of places of parallel tasks, a bunch of decision tasks, some sequential tasks. And they actually start off this function right away with a bunch of chained parallel tasks. And this does all sorts of things. It validates an ID for a recipe. It validates the serving size. It validates the data quality for containers that have more than one serving. And so they're doing all of this work to meet regulatory needs for, in this case, food labels, which is an incredibly important thing. You get that wrong and you get fined. So an interesting use case here. So in terms of pricing, the way that step functions works is you pay per transition. So as you transition from one step of a step function to another, that is what you pay for. And so depending on your region, there are slightly different costs. And all of the regions are actually listed up on the product listing page for this. In most regions, though, it's 2.5 cents per 1,000 transitions. And so again, depending on what you're doing and how many transitions you're having, this becomes a very small part of your AWS bill. So let's dive into a demo for this. And now this is something that you can do yourself. We have a number of different workshops that exist here. I actually didn't talk about them too much here today. But if you go to GitHub and you go to github.aws.com/AWS samples. You'll find in there a repository called the AWS-serverless-workshops. Let me show you this actually real quick. We have a whole bunch of workshops that are serverless workshops. This covers serverless web applications, DevOps, data processing, and so forth. And these use kind of all the stuff we've been talking about here today. But if you come in here to image processing, this one is strictly around using step functions to do a number of things. And so you can come in here and just follow the steps for this and set this up. You can set this up and tear this down, and this will all fit within the free tier for an account, if your account still has the free tier for it. If not, create a new account, and it'll fit inside the free tier for you. And this basically, at the end of the day, you end up with this step functions workflow that you see here. And so what you do with this is it takes photos, it does face detection, it looks to see if that face has already been parsed and stored. If it hasn't, then it will go and add the face to what it calls as an index and generate a thumbnail, and then it persists metadata to a database. And then you can see here that there is a failure state if the photo does not have a face or meet the requirements of the standards. And when you go through this here, it walks you through all the steps. It uses CloudFormation. It goes and launches things and does a bunch of stuff like that. But let's actually go in here and see this thing in action. So if I come in here to the step functions console, I can go and find the existing functions, or state machines, I should say, that I have. And so I have this one here called writer photo processing. And I can go and look at the definition for it. And so, close this out here. The image that we see here, again, lines with what we saw on the website, minus one of the steps that I didn't add yet to this. But so when it comes through again, it will attempt to do face detection. It will check to see if it's already been stored or not. There's also failure state for both of these, which is that the photo does not meet a requirement. Otherwise, it adds it to an index and generates a thumbnail. Now, if we go and we look at the actual syntax for this, again, it's a JSON document. It's in something called the Amazon State Definition language. And what we have here, and we can do things like collapse this down. So it's just basically where do you start, and then there's the states. And then in here, I've got a number of states. So I have a state called face detection. And if you look at just that, there is a type that's called task. There's the resource that it corresponds to, which is the ARN for a Lambda function. There is the result path. So where are we going to go to next? And then it has the next step here. It will catch if there are certain errors. So if the error equals photo does not meet requirements, then it will error out. And basically then go to the next step for that failure. But then, otherwise it goes on to another step. And it will go on to check face duplicate, which is again type task, has an AWS ARN. In this case, doesn't have a failure path assigned to it. Or, I'm sorry, it does have a failure step. It does have this here with the catch, but there's no result path to the next function. That's what I meant to say. And then at the bottom here, we have parallel processing. So this is of type parallel. And then there's two branches here that define two different steps, which also relate back to Lambda functions. So if we go and execute this, and I have an image that is stored, let me go, so this happy face. Just open this up. Cool, so this is the face that is stored. So if I come here into step functions, I can pass in the information that this needs. And so in this example, you pass in the JSON to kick this off. So it already has it stored. And just call this face example. And I can click Start Execution. Okay. Now if I scroll down here, I'll see the event history as it happens. I can also watch in a little diagram, which will refresh here as it executes each of these Lambda functions, what it is that it's doing. So in this case, I have a duplicate for this photo. And so it spits back out that this has failed. Now I can click on any of these, and I can see what the input was and what the output was of the information about it. Now, the first thing that we do here is face detection. And so the face detection function uses, let me close this here, uses a service that AWS has called recognition, which can do recognizing what's going on inside objects and videos and stuff like that. And so it executes. It took, again, that JSON structure I passed in, which had an S3 bucket and an image. And then what it passes back is all sorts of information about this. So it detects here the size of the image. It can determine, for example, approximately where it thinks the person inside of this is aged, if they're smiling or not. Do they have eyeglasses? So it says false. And we know that there's no eyeglasses on that photo. To determine gender, is there a beard, a mustache, things like that. There's a bunch of things that it passes back. It tells me what type of emotion it thinks it has, and it thinks that the person is happy, so that's good. And then some other aspects about it. Now, if I click over here onto the check face duplicate task, I can come in here and scroll right down and go into the outputs. And so one of the things that step functions does is it continually builds the input and output up for you. So it's merging in the inputs from the previous step into the function, and then the outputs typically contain all of that information as well. So I have all of the previous information about the face, but then when I get down to the bottom here, I see that the face in this is already in the system. So this has already been added to this. It exists. So let's go ahead and try something different here. I'm going to put into this S3 bucket another photo that I have. Which is my badge photo. Let's see what happens with this. So I'm just uploading a file in S3. Should be pretty quick. Cool. So I have this here, so let me go and copy the name of it and come back to my JSON. Oops, just paste this in here. Oops, I just want this part actually. Copy it, and let's do a new execution and see what happens. My photo. So again, I'm saying in my bucket, use this photo, and do this thing. So it's going to go through the workflow again. It's going to do face detection, and hopefully my face looks like a face. Otherwise, that'd be weird. And as we can see here, it went through really quickly. So face detection, let's go and see what it says about me. Thank God there's not like an attractiveness in here. That'd be kind of embarrassing. So am I smiling? It says true. Age range, wow, that high one is really high. I'll take the low, I guess. Not wearing sun, so it's a copy of my badge photo here, my Amazon employee badge photo, so it's just basically a headshot type of a thing. Beard, true, that's fair. Eyes open, so on, and thankfully there's only a 9% confidence rate for being disgusted. No. I'm happy, so it got me about pretty much right for happy, so that's cool. And then if I go through here, so was this a duplicate face? Let's come all the way down to the output from this, and it was not a duplicate face, so there is no exception that is captured, so that's good. And then I can go down and see what else it did. So it went and added the face to the index for recognition and generated a thumbnail, which it put into a different bucket. And so we can go into that bucket. Actually, let me get that bucket from here. Sorry, 1 second here. Where's the no buckets? And I have in here an image which has been resized by a Lambda function, and that's really small. Cool. So what we saw here is, an example of, and again, if I ran this again, it would fail the check duplicate face thing. Let's try something completely different here. Let's actually put into our S3 bucket something that is not an image. And I'm going to put in a screenshot. Oh, actually, that's an image, so not that. We'll put in a Python or a PowerPoint template just to show the failure state here. Probably could have used a smaller file, but that's okay. Cool, so I have a PowerPoint template. Let's go ahead and let's just copy path, pass this into here. Oops. Do a new execution. Sorry, 1 second. Call this break. Cool. So face detection ran. I bet in the output here it says that, yep, this does not meet the requirements. It is not a JPEG or a PNG. And so it went and did the failure state and would pass this message back out. Now, again, if we went and actually dove into what the Lambda functions are doing here, and we can go and look at the actual definition of this here, we can go and look at the various executions that have happened. So the myphoto execution, we could actually now go back and do an audit of things, so if something went wrong. And so I can come back here and I can see for the Lambda function that was generate a thumbnail. I could dive in and go and look at what the code for this was and see that it's really pretty basic, again, without error handling, talking to the service to get that data. But anyway, the key point here is that I could find everything about the execution event history, be able to dive into individual logs or see what the function's doing. But in this case, this one succeeded, and so that's good. Cool. So saw kind of really briefly here, I didn't go through and actually create the step function on a fly. But with the DSL, the JSON structure to do that, it's not terribly complicated. And again, what we saw was a workflow, predefined failure states for the functions that were there. And my function code didn't have any of that logic. So those Lambda functions could have been executed individually. They could be executed via some sort of event source or with step functions. But in this case, the failure, the retries, any of that would have been handled just by step functions. So with that, we've covered step functions here today. Again, step functions allows you to remove orchestration from your code and pass it up to a managed service. Pretty powerful stuff when it comes to building highly scaled architectures of distributed systems. You can find out a lot more about step functions in AWS, amazon.com/serverless. Again, the white bar that you see here has links to resources such as getting started guides, documentation, case studies like some of the ones that we saw here today about some of the step functions customers, as well as other webinars, talks, blog posts, et cetera. And then as well as links to all of the products that we've talked about here in the serverless space. Just kind of wrapping up here today again. For those of you who've been attending, we will have decks sent out and available to you, so you can come and go back and look at the slides. For the users of you who've been watching on Twitch or want to see the Twitch videos, I believe these are all being recorded and will be made available later on. Cool, I got a thumbs up from the Twitch team for that. So you can come back and watch these videos or check on the ones that you haven't seen. Catch us, I think, online here again today, tomorrow for the next day in the reInvent recap. Where again, this week we're covering all sorts of recaps from the recent launches and new updates that happened at AWS reInvent 2018. This is the close of serverless day. Again, my name is Chris Munns. I'm a principal developer advocate for serverless here at AWS. You can find me at munns@amazon.com or at Chris Munns on Twitter. And we appreciate you joining us both on the live stream and then for those of you who are here in the San Francisco loft. Again, we've covered a number of things today, from Lambda to API Gateway to step functions, SAM and SAM CLI, layers and runtime. The serverless ecosystem has even more than this than what we covered. And so again, do check out the serverless landing page for kind of the rest of the portfolio of products. And again, thank you for coming, and we hope to see you both here in the loft and live on Twitch again soon. Thank you.